Good afternoon, everyone. I have 4 p.m. Eastern Time. Welcome to the 2021 Hurricanes at Home webinar series that is being put on by the National Hurricane Center and also the folks at the University of Rhode Island Interspace Center. They're helping out as well today. We're happy to have everyone on today for the webinar. You can ask questions throughout the webinar in the question and answer box that you should see in the bottom right-hand corner of your screen. There'll be a few of us that will be answering questions during the webinar as best we can, and we'll save some of those also for the end. We'll have about a 40-minute presentation by a number of panelists, and then we hope to save about 15 to 20 minutes for your questions and answers to get through as many of those as we can. With that, I'll ask Robbie if he can move to the next slide. And unfortunately, during the 2020 hurricane season, we had 30 named storms, a record-setting season. And I don't think I need to introduce a lot of these storm names to you, because if you live along the Gulf or the Atlantic coast of the United States, you probably had to deal with some of these storms last year. Some of them were quite impactful. We had 11 storms that made landfall in the United States, including 6 hurricanes, with the strongest of those being Hurricane Laura that struck portions of Louisiana. And we're going to talk about some of these storms as well as how we forecast these storms, what some of those hazards we need to be concerned with, and again, how we track and collect data inside those storms. So Robbie, if you can go to the next slide, I'll introduce our panelists that we have here today. I'm going to start here with Nikki Hathaway. Nikki is a flight meteorologist at NOAA's Aircraft Operations Center. Nikki will be joining us later in the webinar and will be around for those questions and answers. So if you want to know how we fly into hurricanes, be sure to ask her those questions. Jessica Fieux is a lead forecaster at the National Weather Service office in Tallahassee, Florida, and she's going to talk to you about how the local offices coordinate and work with the National Hurricane Center to provide that local information when a hurricane is threatening your area. I'm also joined by Chris Knowlton at the University of Rhode Island Interspace Center. Chris is going to help us with our polls today, and he can also help me a little bit handling some of your questions as well. And then from the National Hurricane Center, I have John Cangialosi, who's going to also help me with the questions that we expect from you today. And then Andy Latto is going to help with the second portion of the presentation. Andy and John are both colleagues of mine. We're forecasters within the Hurricane Specialist Unit at the Hurricane Center. And Robbie Berg is also one of the forecasters with me in our Hurricane Specialist Unit. I'm going to turn it over to Robbie right now to begin our presentation.
Hey, thank you, Dan. The slide here says good morning, but I guess it's really, if you live on the East Coast, the Central Time Zone, it's really good afternoon. It's not the morning anymore, but thank you for joining us today. As we talk about hurricanes and the jobs that we have at the Hurricane Center and within the National Weather Service and other places within NOAA, we wanted to kind of start here by saying, we're all meteorologists. So, what is a meteorologist? You can actually see on your screen here a few examples of meteorologists. You can see some computer screens, maybe somebody there. You can actually see Dan there in the lower right portion of your screen. He has a microphone in his face. We're in front of some weather maps, some satellites. So, what is a meteorologist? Well, a meteorologist is actually someone who studies or forecasts the weather. And that can be any type of scientist who studies or forecasts the weather. So for example, we at the Hurricane Center, we're actually looking at the computer models, looking at satellite imagery to make a forecast. Many of you probably watch your TV news in the evenings or at night, or maybe even in the morning, and you see somebody standing in front of a weather map telling you what the weather is going to be that day. That person is also a meteorologist. They're predicting and studying weather, except they're not doing it in an office like ours. They're doing it in a TV studio to tell you what to expect when it comes to weather. So there's all different types of meteorologists, but we're all the same thing in that we study and forecast the weather. Now, in my office, the National Hurricane Center, we're a part of a larger group of people called the National Weather Service. So you might be asking yourself, where is the National Weather Service? Well, if you look at this map here, you might be able to pick out kind of the area where you might live in the United States. And the fact is that the National Weather Service is everywhere. We have offices all across the United States, all across from the East Coast to the West Coast to Alaska, Hawaii, even Puerto Rico and Guam and American Samoa. So every portion of the United States is covered by the National Weather Service. Now, if you're watching from other countries, if you're joining us today from other countries, you also have weather services in your country. So for example, we work a lot with Environment Canada up in obviously Canada. Every country in the Caribbean, we work with the meteorological services or the weather services from those countries as well. So no matter where you live, you are covered by an office or an agency that predicts the weather. In the United States, we happen to be called the National Weather Service. Now, within the National Weather Service, as I said, I and John and Andy and Dan, we all work for what's called the National Hurricane Center. And we're located way down in the southern tip of the United States in Miami, Florida. So we wanted to say greetings from Miami. That is our building, as you can see there on the screen. That's the building we normally work in. As of right now, because of COVID, where most of us are still working at home, working virtually, but we still do go to the office whenever we have big hurricanes that we have to forecast. Now, where do these hurricanes occur? Well, for us, we're worried about hurricanes that are located over the Atlantic Ocean and also over the Eastern Pacific Ocean. So we're not just looking at storms in Miami, we're actually looking at storms over a very large area, again, stretching from the Atlantic Ocean almost to Europe and Africa, all the way west to the Caribbean, to the Gulf of Mexico, and then across the United States and Mexico to the eastern part of the Pacific Ocean. So again, we cover a very large area, watching storms, forecasting storms, and also forecasting what we think those storms are going to do. But that's not all we do. We also have a group of people at the Hurricane Center that are worried about boaters, people who have big boats, small boats, maybe people that work on oil rigs, as you can see an example there on your screen. The group of people at the Hurricane Center that work in this group, or sorry, this part of the center are called the Tropical Analysis and Forecast Branch. And what that group does is they tell boaters, big ships there like cruise ships and other people who spend time out on the ocean what the weather's going to be like. So they might be concerned about the wind. How strong is the wind going to get? They might be concerned about how big are the waves going to be. If you've ever been out on a boat, you know that the waves can be a big problem. You might often get seasick if the waves are really big. So it's our job to tell people who are out on the high seas, what those waves might be like. And as you might expect, if there's a hurricane nearby, then the waves get really big. And we really don't want people to be in those areas because it's just not safe for them to be there. Now, everything I've covered here is what we do at the National Hurricane Center. Again, we're part of the Weather Service. But within that Weather Service, I talked about all those other offices across the country. And so first what we're going to do is we're going to hand it over to one of our colleagues, Jessica Fieux, and she actually works at the Weather Service office in Tallahassee, Florida. So Jessica, take it away, and I'll run the next few slides for you.
Thanks, Robbie. So as Robbie mentioned, the National Hurricane Center covers Atlantic to Pacific, but for us, we only cover 48 counties in a tri-state area that covers Southeast Alabama, Southwest Georgia, the Florida Panhandle, and the Florida Big Bend. So we have a much smaller focus than the National Hurricane Center. So you can see a picture here of the Weather Forecast Office. We have the outside of our building. We're co-located at Florida State University. That's the picture you see here on the left. You can even see our hurricane shutters down before one of the events. And then you can see the inside of our operations center on the right-hand side. When it comes to a hurricane event, we always have extra people that we're adding. And this is from a couple years ago when we were all kind of clustered around listening to what the National Hurricane Center had to say. So for us, our responsibilities are to focus on the impacts, messaging, warnings, and forecasts for that tri-state area that we cover. And if we go to the next slide, you'll see some of those specifics that we're responsible for. So we focus on forecasting, and in a tropical event, we're getting our information from the National Hurricane Center. So Robbie and John and Dan and Andy, and then we localize that to our area and we share that information with you. So we localize that forecast information. We're also responsible for collecting data. So for example, right now we release 2 balloons per day, and that goes into the models to help us create a better forecast for you. During a tropical event, the National Hurricane Center can actually ask us to release balloons 4 times a day. So we'll do these special soundings. So you're seeing the picture in the middle or the video in the middle, and that's us on the roof of our building releasing one of these weather balloons. And again, those go into the models to help create a better forecast. We are also responsible for messaging. So it's great, we put out the forecast for everyone, but we want to make sure everyone knows what to do with that forecast. You know, to make sure you go get your bottled water and you have your supplies on hand and when the bad weather might start. And so we do that through social media. We'll do that through conference calls with our partners, or we call them webinars. We'll do that through working with our media partners in terms of doing interviews. And we'll also be on site if our partners request that. So we could go to an emergency operations center and be there to answer their questions. In addition, if we go to the next slide, we are also responsible for watches and warnings across our area. So we talked about collaboration before with the Hurricane Center between the local offices, but the National Hurricane Center issues those watches and warnings for tropical events right along the coast. And then we decide what watches and warnings we're going to put a little bit further inland. We're working on that pre-event, so before the hurricane gets to our area. Once the hurricane gets to our area or approaches our area, then we're focused on issuing flash flood warnings, tornado warnings, and extreme wind warnings. And if we go to the next slide, you know, you've heard a couple times collaboration, but everything we do of forecasting and messaging and helping to provide you all the information you need to prepare for an event, we do that with all of our partnering agencies. So the National Hurricane Center, you know, we're all one agency, but we have different responsibilities, but we work together to make sure that we are providing you the best forecast possible. So Robbie, I will send it back to you.
Great. Yeah, thank you, Jessica. Yeah, and you know what the job that Jessica and her colleagues do in offices like Tallahassee are very critical, because we at the Hurricane Center, we're looking at such big picture. We can't focus in what might actually happen at your house, but she's much more able to do that because she's focused on that smaller area. So we can't do the job without offices like hers. So let's get into a little bit of the science of hurricanes. So on your screen now, you actually are probably seeing a satellite image or satellite loop of a hurricane. So if you're looking at this hurricane, let me ask the question, what are the parts of a hurricane? Can you identify what you're seeing on this screen? So you're noticing these are all clouds. If we're looking from a satellite way up in space, and it's looking back down at the Earth, and it's taking a picture of the clouds that it sees. And this happens to be Hurricane Harvey back from 2017. And you can see that the satellite is seeing the eye of the hurricane here at the very center of the storm. That's what we call the eye. See how the eye is practically clear? There's not much cloudiness within the eye itself. So that's one of the hallmarks of an eye. If you were to be in the eye of a hurricane, in a lot of cases, you can look up at the sky and either see blue sky, or if it was nighttime, you'd see the stars. All around that eye, we have what's called the eye wall. That's where the strongest thunderstorms, the strongest winds are all located. So once that part of the hurricane goes over you, then you would see the strongest winds of the storm. Then all around the side, and I think I saw somebody in the chat mention it, is these spiral rain bands. So it's not just the center of the storm we have to be concerned about, but it's also all the rain bands out on the edges, because they can also produce damage. Not just with the wind they have in them, but sometimes we can see tornadoes in those rain bands as well. And we'll talk a little bit about that later on. Now, once we know we have a hurricane, we then like to group those hurricanes based on how strong it is. And we do that by using what's called the Sapphire-Simpson Hurricane Wind Scale. It's kind of a mouthful, but it's an important scale. And you can see the scale there. What it tells you is how strong is the storm in a 1, 2, 3, 4, or 5 scale, depending on what are the highest winds anywhere within that storm. So in other words, if we have a storm where the highest winds are between 74 and 95 miles per hour, we call that category 1. And when a storm is category 1, we say that the winds from that storm can produce some damage. Now that goes all the way up to category 5. That's when the winds in the storm are 157 miles per hour or stronger. And if those types of winds occur at your house, then unfortunately we do expect what's called catastrophic damage. So when we've seen category 5 hurricanes hit areas, the wind from those storms tends to damage and destroy just about everything in its path. So again, we categorize these storms based on the wind that it's producing. And you might have noticed in that name, Sapphire Simpson. That's because it's actually named after these two men, Herb Sapphire and Robert Simpson, who got together and looked at how storms were causing damage, and they related that damage to the winds in the storm. So that's how we came up with that scale. Now, one thing I didn't mention is on that scale, anything that's a 3, 4, or 5, we call that a major hurricane. So those are the strongest of the hurricanes. So the question we're asking now on this slide is, where do major hurricanes move over the Atlantic Ocean? This map is showing you every place that a hurricane has moved, and in the yellow is specifically where the strongest storms have hit, the category 3s, 4s, and 5s. So if you're located here along the Caribbean Sea and some of the islands there, or in Central America, along the coast of Mexico, and then even everywhere from the Gulf of Mexico to Florida, all the way up the east coast of the United States, what do you notice? Just about all of those areas are covered not just by hurricanes, but in many aspects also major hurricanes. So we show this picture because it really says that if you live in any of these areas, you are susceptible or vulnerable to hurricanes. Okay, so all of us need to be prepared. And now that it's May 12th today, and we know that hurricane season begins on June 1st, now is the time that we have to prepare, because we need to be ready if any of those storms happens to move over our area. Now, when do we see the most hurricanes? I just mentioned that hurricane season officially begins on June 1st. But if you look at this graph, you'll notice it shows you when the most storms tend to occur. So if we're at June 1st, we're at this area where it's kind of low on the graph. It's not very high, but as you get through June and then July, and then we get to August, you notice that all of a sudden the graph starts to go way up. And the reason for that is because once we get to August, September, and October, that's when the environment is the best for a hurricane to form, and it's the best for a hurricane to get its strongest. So that's what we call the peak of the hurricane season. And that's why you see a peak here, kind of where the graph goes up and then it goes down. Okay, so September 10th is actually technically what we consider the peak of the season. And we don't always have a storm on September 10th, but if we take an average of all hurricane seasons, that's when we tend to see the most. You might notice also there's this kind of secondary peak as we get into October. So the graph goes down, but then it kind of goes back up a little bit. And that's because once we get to October, we kind of see this secondary maximum of storms. We're often looking down in the Caribbean, and storms can come up from that area in October and affect some of us here in the Gulf of Mexico or the southeast coast of the United States. So June 1st through November 30th is the official season, but again, most of our storms occur in August, September, and October. Now we get to get you guys involved in this webinar by asking you a question that you get to vote on. If I was to ask you, what are the primary hurricane hazards, which would you choose? And your choices are A, high winds, B, storm surge, C, heavy rainfall, D, dangerous surf, and E, all of the above. So you should be able to see the poll on your screen, and go ahead and answer to the best of your knowledge which of those answers you think is correct. And we'll give it a minute or so here to get the answers in.
And Robbie will let folks answer the poll. At least on my screen, there's a gray box ahead in front of the slide at the moment. I don't know if that's showing up on your screen or not, but it just showed up.
That's actually the poll question. So let me move.
Oh, there it is. There it is. We've got it now. So, So answer the poll question. We'll give it a minute or so. I see a lot of great questions have been coming into the chat box. I know John and I and a few others are helping to answer some of those. There's a couple that I'm going to save for the end, some really great questions. So keep those questions coming. And Chris, I'll let you close the poll when you're ready. I don't know if you have to wait a minute or close it, but I'll let you close it when you get a chance, and then you can report to us on the results of the poll. Hopefully, everybody got this question right. I do see the results come in. I'm not sure if you can see those, Robbie, but we had 82% say E, all of the above. So I'll let you give the answer.
Wow, you guys are superstars. That's incredible. So E is actually the correct answer. So every one of those hazards that you see there on your screen, strong winds, storm surge, heavy rainfall, and dangerous surf, and by surf we mean the waves at the beach, all of those can be a significant hazard during a hurricane. So congratulations, that's incredible that what was it, 80 some odd % of you guys got that correct. So good job. So now what we're going to do is I'm going to pass it on to Andy, who's actually going to talk about those particular hazards that you just had in that poll question. So I'm not see if I need to.
Chris just has to switch us around, I think. There we go. Thank you, Robbie. Thanks, Chris. All right. So we have an abbreviation called SWIFT, which can highlight the hurricane hazards. And so S would stand for storm surge, W is wind, IF inland flooding, that's from heavy rainfall, and T for tornadoes. Now I'm going to ask you guys another question, and this is going to be a tough one. Oh, so I'm sorry, last but not least, waves and whip currents. So another quiz question and a full question. Which hurricane hazard has caused the most deaths in the United States? Is it wind, A, B, storm surge, C, flooding, or D, tornadoes? Give you folks a moment just to try to answer that question. All right, just a couple more seconds, and we'll have the results. Okay. Does anybody want to tell me what the polling results were?
Andy, there it just popped up. It looks like 41% of the people said C, flooding. About a third said storm surge, and tornadoes was third with 16%, and last was wind with only 4%.
Okay, so the bulk was between storm surge and flooding, and you folks are on the right path. The correct answer is storm surge. So a misconception, a lot of folks think about wind when they think of a hurricane. It's like, oh, how strong are the winds going to be? Is it going to, put the shutters up? They focus on the wind. And that it is a very destructive force in hurricanes. However, what we find is that in the past, in what statistically is showing that it's water is what people don't think about is what we should be thinking about, because water is what kills the most from a hurricane. Storm surge accounts for nearly half of the fatalities in the United States, while rainfall, the flooding caused by the heavy rainfall, is about a quarter of the fatality sources. While you have a lot of these smaller values for surf, offshore incidents like on boats and vessels, wind accounts for 8% and tornadoes are only 3%. Here's a good example of what storm surge looks like it's capable of doing. These are homes that were displaced, taken completely off their foundations from that moving water. The storm surge is powerful because you have this rise of water onto normally dry areas, and water is very dense. Water is very heavy. If you've ever stood there and had rushing water and a wave hit you at the beach and it's only a few feet deep, it can take you down and possibly take you out to sea. That's why rip currents are so dangerous. Same thing can happen to homes. High enough water plus wave action can destroy homes and move them off their foundations. It can sweep cars away as well. That's another reason why the flooding rainfall is such a deadly part from hurricanes. And even tropical storms can cause devastation from flooding rains. It doesn't take a Category 3 hurricane to cause heavy rainfall. Tropical Storm Allison back in 2001 in Houston took this interstate and made it into a river. And so you can see you can get very, very heavy rainfall from slow-moving tropical storms, even tropical depressions. The other hazards, tornadoes and waterspouts. For those of you that don't know, waterspouts basically is a tornado over water, and a tornado is when it's over land. And you can have waterspouts move over land and become tornadoes, and vice versa. Waves and rip currents is kind of a more devious hazard from hurricanes. These develop because of the wave action from these storms. Yes, they can happen when the storm's really close to land or making landfall, but they can also occur when the storm's way far offshore. And that's why it's so dangerous, because you might not think about, okay, they might not be dangerous, but there's dangerous rip currents there and the storm's 500 miles away. And so a lot of folks try to issue hazards along the beaches. Sometimes you'll see these warning flags if you're in the right location. They'll tell you it's high hazard. You shouldn't be going into the water in those conditions. The National Weather Service also issue rip currents advisories to try to let you know that the conditions are conducive for dangerous rip currents. How do we predict these storms? How do we know what's going on with them? So we have to first do what we call an analysis. We have to just use observations from land station ships, buoys, and aircraft, balloons, satellites, radar, to try to determine how strong the storm is, where the storm is, and how big the storm is. We have to answer all those questions before we can even start forecasting. We get all that information together, we put that into the computer system, and then the computers will send that information off, and we get the computer models to try to determine where the storm is going to go in the future based on the data we gave it and based on the environment and the steering flows that are occurring around that region. I'm going to hand this off to Nikki Hathaway from the AOC to give you a brief about, yes, we do fly into hurricanes.
Hi, so my name is Nikki Hathaway, and I'm one of the flight meteorologists that work at the Aircraft Operations Center. And so what I do as a meteorologist there is I actually help to direct the flight through a hurricane. So we have a couple of different aircraft that we actually bring through the eye of the storm, and then one that also flies up and around the storm and really captures the environment surrounding the storm. And you can see those two aircraft in the screen below. So the one on the left, that is Gonzo, our jet. That is our high flyer. So he is flying all around the storm, capturing the environment surrounding the storm as well as over the storm. And then the aircraft on the right, we have two of those, and one is named Miss Piggy and the other one is named Kermit. And that is our heavier aircraft that is a little bit larger in size and goes straight through the eye of a hurricane. Both of which are capturing really important data. Just like Andy was saying, we need to get as best data as we can in the storm environment to be able to put into our computer models. So the National Hurricane Center, our friends over there, will task us with going out and sampling these storm environments to capture the best data that we can to send back to them and go into the computer models to produce a forecast for you guys. The picture on the right-hand side of the screen, we were talking earlier in the question and answer about what does the eye of a hurricane look like? What's going on there? And Robbie even mentioned there's blue skies up ahead over the actual eye of the storm, and you can see that in that image. So inside the eye is actually pretty benign, pretty calm conditions. Sometimes when we're flying in the eye of the hurricane, you'll see some birds hanging out there that maybe got stuck while they were passing through and just got stuck in the eye of the storm. So it's pretty calm conditions. Blue skies during the daytime. At night, sometimes with the full moon overhead, that'll be our night light in the sky. And that's just kind of an inside look in terms of what what a hurricane looks like and what we do at the Aircraft Operations Center. And so I'll stand by for your questions later on after the presentation and pass it back to Andy.
Thanks, Nikki. And I'm sure you folks have a lot of good questions for it. We'll field those as soon as this presentation is over here in just a few minutes. So this is a glimpse inside what the Hurricane Center looks like. The top left-hand corner of your screen is a briefing station where folks can give media briefings that get sent out to anywhere in the country. You'll see sometimes when there's a major United States threat, you might see our director Ken up there in front of the television, and it might be broadcast on national television. But behind that monitor is our operations area where we do the forecasting. On the right-hand side, you can also see the top right. It can get pretty busy in there when there's a lot of storms threatening. And the bottom right-hand side is another glimpse into the operations area at the Hurricane Center. But we have to get the word out to everybody. And it's important that we use all of these avenues to get the data out. So folks might watch television. That might be their preference to look for weather data. Folks might be more remote. They listen to the radio or driving around listening to the radio, or on ships listening to the radio. Newspapers, and then also social media as of recent has been a very powerful tool. We have Facebook and Twitter that we use to get the word out. Hurricane Preparedness Week is going on right now, and so you can access it through the URL down below, and you can get good information about how to prepare, develop an evacuation plan, get a list of goods you need to get through the hurricane season, and determining your risk and where you are. And we talked about winds and surge. You know, a lot of folks don't think about the surge because they might not live in a surge-prone area. But if you do live in a surge-prone area, you do need to know that and take preparation action to make sure that you're going to get yourself out of harm's way if something's threatening your area. I'm going to hand this off to Dan and John, who's been in the Q&A room, so they can ask any questions that have been coming up throughout this talk. Thanks, everybody.
Andy, I was going to see if John was going to pop on. If he's not ready, I can take the first question here.
If I could, I want to say one thing real quick. If you enjoyed the webinar, advertise to your friends and other family members the webinar that we have next week on the 18th at 5 p.m. Okay, go ahead, Dan.
Yes, Andy, that's a good plug for our next one next week. I hope you enjoyed the presentation. I've seen a lot of great questions come in. Really, tremendous number. We've answered a lot already, but keep some of those coming. The first one I was going to pass over to Jessica, if she can pop on from the camera. And early on when you were presenting and you showed the weather balloon, Elise and Liam asked, what does the balloon actually do? What does it measure, and how does it measure that? And how do you get the data back, Jessica?
Thanks, Dan. That's a great question from Elise and Liam. So thanks for asking that. So the weather balloons we released, they have this package on it called a radiosonde. And that radiosonde collects wind data, temperature, pressure, and dew point. So that goes up and up and up till about 100,000 feet. The balloon pops, and that radiosonde, the parachute, the balloon, everything falls back down to Earth. We actually get that data back instantaneously to our office. So we don't have to wait to get that data back via the radiosondes. And then all of that data goes into models to help create a better forecast, or better models to help us make a better forecast.
Great question. Great answer, Jessica. Thank you for that. I got a question. I think I'm going to send this one to Robbie. Robbie, there was a lot of questions. I was kind of impressed by some of them. Let me try to pick one for you because I got to have a few. And it says, when storms, how on average take for the storm surge out of a city? Oh, wow. That's an excellent question. You know, it just depends on the storm. We have some storms where we get the flooding from the storm surge, and it takes days for that water to get out from that city. Especially in places like southwestern Louisiana, where Laura hit this past year, the water just sat in some of those low-lying areas for more than a week, okay, several weeks in some places. So It all just depends on where the storm makes landfall and where that water actually goes. But to answer your question, it can take a very long time for some of that water to drain out. And then, I add there, it can be worse if you had a lot of heavy rain as well, because then the storm surge and the rain combine, and you cause a lot of flooding in that case. So it just all depends on each storm, but it can take a very long time.
Robbie, I had one I was going to throw to you, and maybe Andy may want to comment as well. But I throw it to you because of the amount of work that we've had to do this off season, looking back at the 2020 season. I saw actually two questions. One was from Terrence asking, how do you reevaluate hurricane season after they finished? And the other one was from Christian asking about those changes to the intensities that we make in that after the storm. Before we finalize those reports. So I know you've done a lot of that work this off season.
Right. So, one of our jobs in the off season when we're not forecasting is that we have to go back to the previous season and reevaluate everything. So for every storm that occurred, both in the Atlantic and the Pacific, we have to write a report. So, for example, in the Atlantic this year, we had 31 storms, I believe, if you include the depression. Then we had a whole nother slew of them in the Pacific. So that was a lot of reports we had to write. And what we do is we go back and look at data that maybe we didn't have when the storm was actually occurring. Maybe something, came on our desk after the storm was over that helps us to reevaluate, what that storm actually did or how strong it got. So I'll give you an example. Just yesterday, we put out the report for Hurricane Zeta from last year. Now, Zeta made landfall in Louisiana at the end of October. When Zeta made landfall, based on what we knew at the time, we thought it was a Category 2 hurricane. Well, we went back and looked again, and we had some new data. We looked at some data, looked at some of the data even closer, and we all decided that, no, it actually had winds that were a little bit stronger. So we upgraded it to Category 3. So we do this for every storm in our area of responsibility. We look at all the data and try and decide if there was anything we needed to tweak or change about it. And in some cases, we might end up upgrading a storm, but also other cases we may end up downgrading it. So we do a lot of work in the off season to do this post-analysis of the storms. I'll say for me in particular, I also do a lot with the storm surge. So we look at all the storm surge observations that we get, how high did the storm surge get, and try and determine what was the peak storm surge that occurred from every storm.
Thank you, Robbie. Excellent response. I'm going to send the next one over to Nikki. This one came in as you were speaking, Nikki, but maybe you can actually elaborate a little more on this. It's from Mika, and she wants to know, how can you possibly fly safely through a hurricane? It's a little hard for her to believe, I think.
That's a great question, and we get that question pretty often, actually. So I want to kind of paint a picture for you guys. Everybody has been in a car, and they've been over a speed bump, right? Maybe you're driving through a neighborhood, and your parents or whoever's driving the car slow down a little bit so they make sure they go over that speed bump safely, right? Well, they're doing so by going a little bit slower. They're making sure they're going over that bump not too fast, because if they were to go super fast over that speed bump, the car would become airborne and they'd fly over the speed bump, and that just wouldn't be good. But if we were to go too slow over the speed bump, we might rock a little too slow just over that speed bump and maybe not make it over so easily, right? So our aircraft are actually flying at a specific airspeed, and that airspeed is critical in terms of making sure that aircraft remains safely as it's going through the hurricane. Now, inside of a hurricane, there are a lot of updrafts or areas where wind is being forced upwards. And then, as we were talking earlier about the eye, areas where we have sinking air. And so this up and down motion inside of a hurricane are kind of like those speed bumps that I was talking about in a car. So it's really all about that airspeed and making sure that the whole team on board the aircraft is remaining safe and practicing safety protocols that we put into place before the hurricane season starts. So that's a great question. That's the best analogy I can give to you in terms of if you were in a hurricane, what you would be experiencing.
Thanks, Nikki. I also saw a question asking about whether we at the Hurricane Center use data from the Air Force hurricane hunters. And I'll just say, yes, we do. It really is a team effort. There's both agencies, both the Air Force are flying into storms to collect data, and the NOAA folks as well. And so it's really a team effort to be able to do that. The question I was going to ask, let's see, next was back over to, actually I was going to ask Andy, Someone asked more about our tropical cyclone reports, saying, asking whether or not it's one person that works on one of those reports or whether it's multiple people that are doing those reports.
Okay, that's a great question. It actually, a lot of it depends on how big the storm was, how major of an event it was. For example, we get sometimes storms over open water and only last for a day or two. Typically, one person will handle that report and analyze the data and do the write-up for it. However, the other end of the spectrum, you could have a major landfalling hurricane that crosses over several states. We had unfortunately we had several of those this year, and so there's different folks with expertise that will come in and help out with the report. Robbie helps out a lot with the storm surge. John, who's on the call, also helps create the maps for a lot of these systems for these reports. But others can jump in and help with all the data. There's so much data when a storm makes landfall. You picture a storm crossing Florida and all the weather stations that are there, hundreds and hundreds of pieces of data to assemble and get into these tables. And so sometimes you have somebody else help with just that portion alone. And so, yeah, it could be several people that help out with these reports for a major landfall, all the way down to just one for something very simple. And that actually, and I want to credit the weather forecast offices too, because they send us a lot of information when these storms make landfall in the United States.
Thanks, Andy. Actually, speaking of the Weather Service, we're going to go to Jessica now. So, Jessica, we had a really enthusiastic person asking lots of questions. It was Baxter. He asked a whole bunch of questions. I saved one of his for the end, and I want to send it to you. He wants to be a meteorologist. He actually said, "I want to be on TV or work in a weather building like we all do." So he says, "What do I have to do to get there? Just give me some advice."
Baxter, that is a fantastic question, and it's never too early to ask that question so that you can better prepare for what you want to do. A lot of us, if you asked each one of us, at a very young age, we knew we wanted to be meteorologists. So we're excited to hear that you want to be a meteorologist too, whether it's working with us or on TV. So first of all, you want to focus a lot on math and science in your schooling. Also, skills that we think about a lot more recently would be communication skills. So, practice public speaking. If you can take a public speaking course, that's not going to help you just if you wanted to join the media side, but also if you wanted to work in private weather industry or the National Weather Service. We're doing this today. We do media interviews. So public speaking is always a good thing to have. Once you graduate high school, you're going to look at various colleges that you could go to. To be a meteorologist in the National Weather Service, for example, you need to go get a 4-year degree in meteorology or atmospheric science. And there you're going to focus a lot on math and science classes. But it's always good to explore the other interests because they can help you in your career too. While you're in high school or while you're in college, a great idea too is to reach out to other meteorologists in your area, whether it's folks from the National Weather Service or it's folks on TV or private weather industry, and see if you could shadow them for a day, see if they have intern opportunities that you could go volunteer at their office. For example, Nikki actually came to our office when she was in college, and she volunteered with us and helped us, and she helped in the Tampa office. So definitely take the opportunity to meet people in meteorology before you get to college and high school, or while you're in college and high school, so that you can start forming those connections and getting some career advice from them and everything. But just knowing that you're interested in it, that is a great start.
Thanks. And I saw a couple other questions, people asking about qualifications of folks at the Hurricane Center. Maybe we can cover that as we're answering a few questions. But I did see a question that I can throw over to Andy. Someone was asking about a zombie hurricane. And so I know Kimberly, she asked that question. I know last year we had a couple storms that were in existence that then kind of went away for a couple of days and then came back. And I think you might have written a report on one of those. So I think that's what Kimberly was talking about when she heard the term zombie hurricane last year.
Oh, okay. Yep. So I guess that's a terminology you could use for that. Yeah. So when you see a storm, sometimes these storms can get into conditions where it's really not conducive for their survival. You can get strong wind shear, it can go over cooler waters, and it can lose its characteristics and die out. If it no longer qualifies as a tropical cyclone, and it's either becomes, we call it extratropical, meaning it has cold fronts attached to it, or it just becomes a remnant low, as in it doesn't have any more thunderstorm activity. We'll stop writing advisories on it. However, sometimes these storms can move back into areas that are more favorable for tropical cyclones and hurricanes. And one example last year was Paulette, where it hit Bermuda, became a extratropical storm that had cold fronts attached to it, moved all the way around the Atlantic. The cold fronts died out, it transitioned back and became a tropical storm again. But more oftentimes we don't see that happen. A lot of times we'll see a storm that could die out and then regain thunderstorm activity when the conditions improve. So yes, those definitely can happen. They can be nuisances, but it's something we have to monitor. And a lot of times when we do think there is a chance that it could regenerate, you'll see us as soon as we do the last advisory, we might put it in the tropical weather outlook and keep monitoring it for potential redevelopment.
Thanks for that, Andy. Robbie, I'm going to send the next one to you. This is from Harper, and he says, do all storms eventually dissipate, or can some last forever? So go for it.
So, yes and no. No. So storms in general, if we name a storm, name a hurricane, name a tropical storm, they all will eventually die. Okay, they can't last forever. And that's because, as Andy was talking about, they either might hit cold water, that causes the storm to die. They might move over land, and they don't have their energy source anymore, so that can cause them to die. Or they might become what, as Andy said, an extratropical cyclone, which is they have fronts attached to them. So the storm itself, as a hurricane, it dies. But the energy associated with that storm does not die. So if you were to get into some of the physics, if some of you guys might be in middle school and high school, you might have heard of conservation of energy. We have a lot of energy around the Earth, in the atmosphere, in the oceans, and that energy does not die. So even though a storm itself might die, the energy associated with that storm is going to continue on, and it can help feed another storm somewhere else around the world. So, the answer to that question is that the storm itself is going to die, but we always have weather because the energy around the world always is moving. And so, essentially what the atmosphere is trying to do is trying to restore balance. And that's why we have weather. So I hope I answered that question. It's kind of a yes and no answer to that.
Thanks, Robbie. I was going to send another question over to Jessica. Knowing that occasionally our offices are in the impact area of storms, I was just going to ask you, how does the local office ensure that they can operate during bad weather, either tornado risk or hurricane threat? Because I know the Tallahassee office had to deal with that a couple of years ago. So how is it that folks stay safe at the office and are able to provide continuous service during a storm?
Thanks, Dan. So first off, our mission is the protection of life and property. So we always want to make sure that we are keeping you safe. So if we have a hurricane or even a tornado heading towards our office, or for some reason communication goes down, if you've ever had your internet go down, it can happen for us too, just like it can happen for you. If that happens, we actually have backup offices. For us, our primary is Jacksonville, so they can take over for us and do the same thing we do for you. Our secondary is Mobile, and then we also have a tertiary backup office, or our third level backup office, and that's Houston. And so we have lots of people still supporting us to make sure that we can still issue those watches and warnings and get them out to the public. We went through this during Hurricane Michael, and we're really grateful for our National Weather Service partners in Jacksonville and Mobile that took over for us when we lost communications. They were there and able to seamlessly pick up on everything. And we were still able to see things at our office and we would communicate with them, but they were doing the primary products once we lost communications. We also make sure that we're prepared at the office if we're going to be there a while. So we have air mattresses at the office. You know, we've had practice sleeping in the conference room a couple times now. We bring in food and water. So just like you have to prepare at home, you know, we have to prepare even beyond our backup offices helping us out to take over. But we make sure that we have food and water, that we're in a safe place, just like all of you would do at home.
Thanks, Jessica. A great response. Nikki, I'm going to send this one to you. This was a question says, well, what do hurricanes look like from a distance away? And I was wondering if you can kind of answer it as, you know, from the viewpoint of you flying toward the hurricane, like what does it actually look like from your angle or viewing approach?
Sure. So hurricanes obviously are very big in size. So as you're flying towards a hurricane, sometimes you'll get some of those feeder bands that you'll see on the outside of the hurricane, kind of like the tails on the outside of the hurricanes. You'll have to pass through some of those, so you will see some thunderstorms on your way towards the main system. And then as you get closer, it's going to get a little bit more rainy and a little bit more darker, especially when you start flying through the clouds. So a lot of the times when you're, you know, flying, you're going to have rain on your windshield and on the windows. So you actually see a lot of raindrops, a lot of water, and it can get a little bit dark, especially once you start getting closer and closer to the center of the storm. But when you're further away, you know, it really might not look like anything. Just as you get closer, you start to see more and more of those thunderstorms. And then eventually you'll just see the rain kind of going across your windshield.
Thanks, Nikki. I have a question I was going to send over to Robbie. This one came from Abigail, and was asking, how do we decide when we need to retire a hurricane name?
Oh, great question, Abigail. So, you know, here in Miami at the National Hurricane Center, we're actually a part of a larger group of countries. As remember, I was talking about the Caribbean and Mexico and Central America. Well, all of those countries get together and meet every spring about the April timeframe. And what we do is we look back at the previous hurricane season and we take a look at those storms that may have caused a lot of damage or may have unfortunately killed a lot of people. And so then what the countries do is they look at those storms and they essentially all vote on which storms they think we should retire. So if the storm did a lot of damage or if it killed a lot of people, then most of the time the countries will agree that that particular storm should be retired. So for example, this past year, we know we had some big storms and the countries voted and we voted to retire Hurricane Laura. So we have done that so that now Laura will never be used again. Okay, and we have a name list that every 6 years we repeat names. So it's like a 6-year cycle. So when we get to 6 years from last year, we won't be using Laura again in that list, and we actually replaced it with another name. There's one other big change that we made this previous April when we had that meeting, is that you may have remembered from last year, we started using Greek letters to name some of those storms. That's because we had so many storms that we actually ran out of the normal name list that we use in the Atlantic, because that name list stops at W. And so we went to these Greek letters. Well, the committee decided that we didn't like that. We don't want to use these Greek names anymore because it just confuses people by using those names. They don't sound like normal, human names. So we retired that whole list of names, the Greek letters, and we've added a new list that we can pull from if we ever have that many storms again. So there's many different reasons we might retire names, but the biggest reason is if the storm does cause a lot of damage or kills a lot of people.
Thanks, Robbie. And let's hope we don't need that new list right in 2021. Let's just hope for that. Andy, if you're still there, I got a question for you. I'm sorry to put you on the spot. Let's see if you know the answer to this one. If you don't, I'll give you a little backup. First, I want to know, this is from Henry. He wants to know how rare Category 5 hurricanes are. And then maybe you can speak about how many Category 5 hurricanes have actually affected the United States.
Category 5 hurricanes are fairly rare. I'm trying to remember the exact number. It's only been a few that have actually hit the United States in the past few decades. You guys are better at the stats than I am. If you can remember the exact number, feel free to chime in, but they are not very frequent. Michael was a Category 5 when it made landfall, but I believe that was the first time, was that since Hurricane Andrew, was it not, that made landfall in South Florida? So that's a time span
That's
of
correct.
Over 20, doing my math, 20,
6 years.
28 years between the storms. So yeah, but they do occur out there even that don't make it to land. Dorian the devastation to the Bahamas, fortunately, never made it to the United States. So that was one just from the year prior. And Irma was a Cat 5 at one point the year before that. So they do happen out there. They're not very frequent. They need a lot of ingredients to come together just perfectly to make them happen, but they do happen.
Yeah, thanks, Andy. I appreciate that. Sorry to put you on the spot as well. But just to kind of finish up that answer, if you don't mind, and I'm sorry I can't get my camera to turn back on. I apologize about that. But yeah, Andy, you're right. So Michael 2018 was a Category 5 that made landfall, and then before that was Andrew in 1992, and then you had to go back to like Camille in 1969 before that, and then the Labor Day hurricane in 1935. So they're exceptionally rare to make landfall, but they're out there. They do get out there. It's just the worst case scenario is to get a Category 5 to actually affect land. They don't typically hold that intensity for very long, even when they do happen. So thanks for that, Andy, and sorry to put you on the spot.
Nikki, I was going to send a question to you, but it looks like you answered in the chat box about how many people fly on the plane. So since you answered that one there, I think I'll send one over to Robbie from Tara, talking about the fact that they live in the Tidewater, Virginia area, and a lot of people there say that they're overdue for a major hurricane making a direct hit in either North Carolina or Virginia. And I'll just ask it more generally, but how likely is a particular area to get hit? There's a lot of places along the coastline. Tampa Bay area hasn't been had a direct hit in a number of years. So again, how frequent is it that one of these big cities gets hit by a major hurricane in a given year?
Yeah, so we have to be prepared for that every year because we can't predict exactly where a storm is going to make landfall. Now, for example, the Tidewater area of Virginia, it's a little bit harder to get a major hurricane in that location just because by the time that a storm gets up in that area, it's started to hit the colder water. It's probably started to feel the effects of some of the other weather patterns in the area. So it's very hard for a storm to maintain, say, Category 3 or 4 intensity. Now, that's not to say that it can't happen, and we have to be prepared for that. The other thing I'll mention is that, especially in the Tidewater of Virginia, is it doesn't take a big hurricane to cause a lot of storm surge flooding, for example, in that area. So we've seen tropical storms, even Category 1 hurricanes, where the wind is just right. It's able to push water into Chesapeake Bay, and then we see a lot of flooding occurring in Norfolk and Hampton area, Portsmouth, Suffolk. So, all the areas in the Tidewater of Virginia are very susceptible to storm surge, and it doesn't really take one of the strongest storms to cause that type of flooding. So yes, we need to be ready for the big storms, but we also need to be ready for even some of those weaker storms as well, because they can still produce the hazards. All of those hazards that Andy talked about in the presentation, they can still be a big deal.
Thanks, Robbie. Appreciate that. Just a comment for everybody. We actually have someone listening from Italy. Chada says, "I'm glad I don't have to worry about hurricanes here." So I found that interesting, but she's interested nonetheless. Robbie, I was going to send this one to you. I know you just answered this question, but if others have interest, they can take over too. This is from Christian. He said there's an MCV. So obviously we're dealing with someone who knows a little bit, so which is like a thunderstorm complex over Georgia right now. Can those ever become hurricanes down the road if they go over water? So maybe you want to kind of give that one a shot.
Definitely, yeah. So yes, they can. If the conditions are just right, sometimes we can see thunderstorm complexes over the United States, say over the Southeast. If they move over water and they sit there long enough over the warm water, say of the Gulf of Mexico, and given enough time, sometimes they can become storms. And John, you actually know this one pretty well, Hurricane Barry from a couple of years ago. And we were watching a complex of thunderstorms over the southeastern United States. It moved over the Gulf of Mexico, it sat there, and it just spun up up there in the northern Gulf of Mexico, and it actually ended up making landfall in Louisiana as a Category 1 hurricane. So it's not the most frequent type of development that we see, but it is still something we have to often watch out for because it can happen. Now, being May 12th, it's not something we would expect because we're not even to hurricane season yet, and the waters probably aren't quite warm enough. But as we get into the season, we do watch those thunderstorm complexes.
Thanks, Robbie. It's we got about a minute left. Maybe you can go over just a second, but I wanted to kind of wrap up with one final question. Maybe we can go around the horn and just get everybody to say a couple of words. But again, thanks everyone for joining today. It's been fantastic. Your questions were excellent. I'm glad we were able to get to a lot of those. But I was going to ask each of the panelists, maybe we can start, I'll throw it to Jessica first, and then if you could just name someone, we'll go around the horn, and then we'll come back and wrap things up. But, just to say, what do you find is the most interesting part of your job, and I guess sort of what do you enjoy most about it? So, Jessica.
I would have to say I love talking to the students. We haven't been able to go into the classroom as much, but we've been able to connect with so many students via virtually, like we're doing today. And I think that's one of my favorite parts of the job is just connecting with the different people that we provide the forecast to and help to keep safe. Robbie, I will throw it to you.
Thanks. So, you kind of took my answer. I also like talking to not just students, but, other people about the forecast. But the other thing I'd say about for me is that I have the type of brain where I like to look at things, look at data, almost like a detective, and try and put all those pieces together to come up with, fit the puzzle together, essentially. So I love looking at all the type of wind observations we get, the storm surge observations, satellite radar, and putting it all together to try and come up with the best forecast possible. So I think that's probably one of the most exciting parts of my job. I guess I'm supposed to send it to somebody. So how about Nikki?
Thanks, Robbie. I would say the most exciting part about my job is probably just the fact that every storm is so different. Even if you've flown through a Category 5 storm or a tropical storm, each one presents its own challenges. And, you might expect, think what it's going to be like when you're flying through, or maybe how bumpy it's going to get. And then sometimes it'll be completely smooth. And other times you wouldn't expect any sort of bumps, and it's super bumpy. So I just think just the challenges that are presented with each type of storm is exciting, and not, always knowing what's going to happen. That's part of the forecast, right? Is just making sure that we're going out there and we're capturing the best data we can to better understand these systems. And there's still so much to learn. We've learned a lot. There's always more to learn, and I just love that about the job. Always something new. And I'm going to throw it over to Andy.
Thanks, Nikki. I like to chime in and say, yeah, I like the challenging parts of working for the Hurricane Center. And there's not every storm is straightforward. You have some storms that are more easy than others to forecast. And in my time with the Hurricane Specialist Unit, I've enjoyed the times where, yes, you might be able to, I'd like to say, to be able to beat the computer models. And we actually are fairly good at doing that. If you look at some of the statistics, we have pretty good skill with that. And so I think it's interesting to try to do the best forecast as possible, and to look back and say, like, oh, I nailed that forecast. I made that track really good, or I made that intensity forecast really good. Kind of excites you to know that you're doing the right thing and making a good forecast. I'll pass it along to John now.
All right, thanks, Andy. Yeah, my answer is similar, but I'll kind of say it in a few less words. I mean, I'm just really interested in always helping people. And one of the ways we can help people is to try to get it right. I'm sure you always hear meteorologists are often wrong, if not almost always wrong. So we try. I think I just love the challenge of trying to get it right and do our service to help people and protect their lives and their property. So that's what I love most. And then Dan, I guess you can take us home there.
Yeah, thanks, John. Not much more for me to add, but I also enjoy helping folks and get prepared for hurricane season. And I'll just end by saying, again, this is a Hurricane Preparedness Week. Help us. We got folks like Nikki that are flying into the storms to collect that data to help us make better forecasts. It really takes that team effort. So we want you to be a part of that team and to help get prepared this hurricane season. And, talk to your parents about how your family is going to prepare. Find out if you all live in an evacuation zone. If you do, find that place that you may go and ride out the storm. but start thinking about those things before we get to June 1st when the hurricane season starts. And I hope for all of us this year, we all have a very safe hurricane season. I hope it's quiet. I hope it's not like the last year and it's much quieter, but we will see. We all have to be prepared though each and every hurricane season. So thanks again, everyone. We really enjoyed answering your questions, and we're going to sign off now. Join us again next week, or tell your friends or family to join us for next week's webinar on the 18th at 5 p.m. Thank you.